Assalamualaikum and a very good day. So today, me and my group mates are going to present about our assignment, which is on the active suspension system for subject BMMA 3533. So these are my group members, and our lecturer is IRTS Dr. Muhammad HAFIZ bin Harun, and my group members, myself, BUDRIZ bin BERHAMAN, and my metric number is B0921101119. And with me is HUSNA AMANI, Akmal Faiz, Muhammad AMEER, and TUAN FAKHRUL AMIN. So beginning for the introduction of our assignment, which is on the active suspension system. So for the introduction, an active suspension system is a type of vehicle suspension that uses electronic or hydraulic system to actively control the vehicle suspension components, such as the shock absorber or springs, in real time. The goal of active suspension is to improve ride comfort, handling, and also the overall vehicle performance by dynamically adjusting the suspension settings based on various factors like road conditions, vehicle speed, and also driver input. So I am going to summarize the literature review that me and my group mates have done. So for the first one is advances in active suspension system for road vehicles. The second one is review on active suspension system. The third one is control of an active suspension system based on long short-term memory, LSTM learning. The fourth one is a new approach to controlling an active suspension system based on reinforcement learning. And lastly is the active vehicle suspension with anti-roll system based on advanced sliding mode controller. So that is all from me, and I will pass on to the next presenter. Thank you.
Hello, I will continue our presentation. My name is Muhammad Akmal Faiz bin AZLI. My metric number is B0921102287. Okay, I will continue in first journal, which is the title is Advances in Active Suspension System for Road Vehicle. Okay, for the methodology, I can assume from the article, I got three methodology. The first thing is state of the art suspension elements and system. The second one is control strategies, and the third one key component of modern ASS, which is ASS is standby active suspension system. Okay, the first one, state-of-the-art suspension element and system. It covers elements like mechanical arm, spring, dampers, and active suspension, active component, improving the vehicle performance. Okay, the discussion extend to cutting edge the mechatronic system they are used in production car, such as the magnetic suspension. It introduced concept like variable geometry suspension and series active variable geometry suspension as SAVGS, highlighting their approaches to chassis control and ride optimization. Okay, the second one is control strategies. Recent strike in active suspension system for vehicle, including Magnetic and Michelin in-wheel tech, showcase sophisticated control strategies for enhanced stability and comfort. Mechatronic breakout like SAVGS and PALS contribute to cutting-edge solution, demonstrating the continuous evolution of state-of-the-art suspension element in the automotive industry. Okay, the final one is key component of the modern ASS. Active suspension system feature key component like mechanical arm, spring, dampers, and active element. Innovation include the McPherson strut, double wishbone, and multi-link suspension. Emerging concept offer high frequency response and fail safe features, contributing the evolution of advanced road vehicle suspension. Okay, the result that I get from the journal, there are two. First one is future work recommendation. State of the art suspension element system. It covers element like mechanical arms, spring, damper, and other component to improve the vehicle performance. The discussion extends to cutting-edge mechatronic system used in production cars, including the magnetic suspension. It also introduced the concept like VAGS and SAVGS, highlighting their approaches to chassis control and ride optimization. Okay, the final one is future control strategies. Okay, control strategies for ASS will be more intelligent when used in combination in neural network, fuzzy logic, and generic algorithm methodologies and emerging techniques such as the machine learning. The benefit include making the control focus of an ASS feasible to better deal with the various driving scenarios. Okay, that's all from me. Thank you.
Thank you, Akmal. So I will continue for the general 2, which is review on active suspension system. So from this article, I obtained 3 methodology, which is number 1 is magnetic dampers. General motor create magnetic ride control dampers that adjust their stiffness by changing electric current in a special use it to. Number 2 is active curve tilting. So actually this technology was introduced by Mercedes-Benz in 2015, which can be seen in the S65 AMG Coupe that use sensors and cameras to detect corners. The car's air suspension system then tilts the body towards the turn, not to enhance cornering, but to make the ride more comfortable. So the last one is hydraulic roll control. In contrast to typical suspensions using steel anti-roll bars to control body roll, this hydraulic system moves fluid to the opposite side of the vehicle. It functions like a large anti-roll bar, but without a physical one, and it adjusting to driving conditions. So from this methodology, it able to adapt their stiffness in response to specific driving situations. This implies that depending on how you drive, some car suspension systems may adjust how stiff or soft they are. For example, they can be harder or for improved stability when navigating curves or on uneven terrain, and softer for a smoother ride on highways. So the last one is enhancing ride comfortableness, as passenger would undergo lower lateral loads at a given speed. This design aims to make the ride more comfortable for passengers by reducing the sideways movement they feel when the vehicle turns. At a certain speed, the passengers experience less swaying, resulting in a smoother and more enjoyable ride. That's all from me. Thank you.
Assalamualaikum, and my name is BUDRIZ bin BERHAMAN, and my metric number is B0921101119, and I will be continue uh, along. So my journal is about the control of an active suspension system based on long short-term memory, LSTM learning. So for the methodology, for the first one is the intelligent neural network control with RNN, which stands for recurrent neural network. And the second one is the comprehensive analysis of suspension system types and controllers. So for the first one is the study employs an active suspension system model using a recurrent neural network, RNN, specifically long short-term memory, LSTM. It aims to enhance stability in heavy vehicles amidst diverse conditions such as weight, mass, road deformation, acceleration, and also braking. For the second one, the comprehensive analysis of suspension system types and controllers, the study categorizes suspension system into passive, semi-active, and active types. It analyzes the required servo system for active and semi-active suspension, exploring controllers like PID, MPC, SMC, and neural networks, both linear and nonlinear. And for the results, And for the first one is the integration of AI in real-time control. So the research successfully showcases the integration of artificial intelligence, AI, into real-time suspension system control. The intelligent neural network adeptly adapts to changing conditions, learns from the previous states, and accurately predicts outcomes, effectively achieving the desired compromise between various constraints. And the second one is optimized driving comfort. The utilization of advanced control methods and intelligent neural networks is anticipated to optimize driving comfort by minimizing body oscillations, which are rolling and pitching, and reducing the impact of road irregularities on passengers. That is all for me, and I will be passing on to the next presenter. Thank you.
Okay, now I will continue our presentation. Before that, my name is Muhammad Amer and my metric number is B0921100071. So for my journal topic is a new approach to controlling an active suspension system based on reinforcement learning. So there are two methodology, which is first one is influence of the suspension on the human body. When driving a vehicle on the road, the wheels may encounter any obstacle with random distribution, both spatially and temporally. This unevenness in the road can lead into vibration movement. When the whole body is subject to prolonged vibrations, it is harmful effect on the organ of the human body. The second one is suspension system study. Several studies have investigated the different types of vehicle suspension system from the point of view of complexity, efficiency, maintenance, and lifespan. This study shown that the electromagnetic actuator is more efficient than the hydraulic actuator, given its simplicity of manufacture and dynamic behavior. The high cost of manufacturing and system maintenance also pose problems in terms of efficiency. So for the result, they also have two. The first one is choice of algorithm. The agent's decision-making function represent a mapping of situation to action. Given the importance of choosing an algorithm, performance study of this DRL algorithm are carried out. According to a comparative study of the behavior of algorithm on the stability of drones, it was noted that the TRPO and DDPG algorithm have extreme oscillation. The second one is numerical modeling. For this study, we opt reinforcement learning because the latter requires a large amount of training data, which can be difficult to collect for real-world driving scenario. This model consists of two suspended and unsuspended mass, respectively sprung mass and unsprung mass, supported by two shock absorber and two springs. This model is similar to the passive model, but includes an actuator between the sprung and unsprung mass. So basically, numerical modeling is to create and calculate the calculation for active suspension system. That's all from me. Thank you.
Hello, my name is FAKHRUL and I will be presenting my Journal 5 regarding active vehicle suspension with anti-roll system based on advanced sliding mode controller. For methodology, by referring the article, first one is vibration isolation system, proposing an intelligent vibration isolation system featuring the advanced sliding mode controller for energy efficient vehicle suspensions. The article advocates task division, anti-roll bar utilization, and quality preservation without heightened energy consumption. The ASMC successfully minimized both roll and vibration. Research may extend to a comprehensive vehicle suspension model. The second one is suspension design and control algorithm. Examining the application of anti-roll bar in different vehicle segments to control body roll. The text delves into solution for designing and implementing control algorithm for specialized vehicle like high mobility, multi-purpose wheel vehicles. It highlights the positive effect of reducing body roll on aspects such as handling, traction, grip, and safety. And the last one is sliding mode control for torque in anti-roll bar. The application of sliding mode control is employed for the precise regulation of torque in active anti-roll bars within road vehicles. The approach involves defining sliding surfaces and setting limitation for the controller of the active roll control system to effectively minimize the roll angle. And for the result, the first one is SMC impact on roll and vertical displacement. The applied SMC successfully mitigates vehicle roll without substantially impacting the reduction in vertical displacement. The primary role in reducing vertical vibration is assigned to the LQR controllers linked with suspension struts. And the second one for result is roll reduction without increased energy demand. Reducing vehicle rolls without rise in energy demand is the key benefit of the proposed system. This is made possible by the ASMC control structure, which employs the LQR method for vertical vibration reduction and the sliding mode controller for effective roll reduction by directly managing suspension strut. And the last one for the result is effectiveness of ASMC controller. This article outlined in the paper indicates that the advanced sliding mode controller proved effective in diminishing both roll and vibration in vehicle suspension system, evaluated through simulation using software in the loop method. For conclusion, an active suspension system is a type of vehicle suspension that uses electronic or hydraulic system to actively control the vehicle's suspension components, such as shock absorbers or spring. The goal of active suspension is to improve ride comfort, handling, and overall vehicle performance by dynamically adjusting the suspension settings based on various factors like road condition, vehicle speed, and driver input. And this is the reference for our studies. I think it has reached the end of our presentation about active suspension system. Thank you for listening, and Assalamualaikum.